Day 2, exponent logs review. We'll keep it just to this for this video. So solve an exponential equation whose powers can be written with the same base. So that's where we need to convert, you need to have the exponent knowledge to convert the 9 and the 27 to have the same base. In this case, they're going to be a base of what? 3, right? And so that's something we want to do. The other move we need to be able to do quite easily is that 4 through 3 is pretty ugly. We need to be able to write that as 3 to the 1/4. So what I would do first here, if it was me, I'll keep the 27 here, and I'd just do it like that. So now I'm good. I can see I'm going to go base of 3 for everything, and that should be fairly easy. So when you do that, 9 is 3 squared, so that's 3 to the 2x, equals 3 cubed times 3 to the 1/4. Okay, now 3 to the 1/4, do I add those or multiply them? We add them, right? Make sure you get your exponent rules. Now, it's going to be a little ugly because we got to get a common denominator to do that. You have to do 3 plus 1/4. So you got to go 3 in terms of force. I know you hate when I say that, but to me, hopefully with your time, you'll get it. But 3 in terms of force would be 12 over 4 plus 1/4. 12 over 4 is 3, right? So then we would be here. 3 to the 2x equals 3 to the 13 over 4. And now we're good to drop the bases and solve from the exponent. So 2x equals 13 over 4. Divide the 2, divide the 2. That gets me x is 13 over 8. Okay. Can't just drop the 3's and what? 3. Multiply, drop the 3's. Yeah, sure. Drop the 3's. But you mean right here? You can drop them, but it's still addition. It's not times. Okay, because if you drop them and multiply, you'll get a different answer. You'll get 3/8 instead of 13/8. So I prefer to only drop once it's 1, 3 on both sides. Okay. Next piece, solve an exponential equation whose powers cannot be written with the same base. This one you can't do the same base. This is where you're going to want to use your logs. Okay, that's the indicator, because remember, logs help get rid of that stuff for us. So how to solve by graphing. So remember, you can solve this by graphing. You can put in y1, 1.04 to the x, and y2, you can put 2 and look for the intersect. Okay, but we also can do it by logs as well. So we'll do the logs because I think the calculator way you probably should be fine with. So I'm doing this one. I would just go, you can go change to log form, or you can log both sides. It's up to you. Again, I'll do both ways. So if I change this to log form, it'd be log base 1.04 of 2 equals x. And then we do change a base, log 2 over log 1.04. Okay, and then that would give me 17.7. Okay, and if I do log both sides, drop the x, divide, divide, and then we get the same thing, right? 2 over 1.4, 2 over 1.4, 17.7 again. So that's just the two ways to do it. Whichever one you like is fine. Okay, if you're still struggling converting from exponent form to log form, that needs to be down packed by the 23rd. You got to make sure we get that taken care of. So it's right there for you again. Y equals b to the x is the same thing as x equals log base b of the y. Okay. So let's just go ahead and practice those. All right, so write log as an exponential expression. So it would be 3 to the 4th equals 81. Write as a log expression. Log base 6 of 36 equals 2. Just a quick little flip there. Okay. As we move forward here, move to your log laws now. Okay, so remember your log laws. You got your addition is the multiplication of an argument. Your subtraction is division of the argument. Your exponent in the front is when you have an exponent on the argument. You can drop it out in front. So coming to that, simplify the following and express this logarithm. So I want me to condense this to one logarithm. So when you do that, we want to push the 2 up to the x. So log a of x squared now. Nothing else here. We'll leave it. Push the 3 up to the z. And so now we're ready to use the plus and minus rules for division and multiplication. Okay. So one thing that's important here is that if it's minusing something, it goes in the bottom. If it's addition, it goes on the top. So if you have a combination, you just kind of have a top group and a bottom group. Okay, so like for example, if this plus was on the end, it would still go on the top. Okay, it doesn't matter. Now, what would change that is if I had a bracket. Now, if I put minus the bracket of log, if it looked like this. If I did this, log a z cubed, that means this whole group is being divided at the bottom. And they're multiplying each other on the bottom. That's what that means. Okay? So just kind of keep in mind of how that works. Okay? So, but for this one's pretty straightforward, though. This one's simply going to be log a x squared y over z cubed. So multiply the x squared and the y minus divide the z cubed. Okay, any questions there? Okay, hopefully I didn't confuse you with that other part, which I think we had one like that on one of our tests or quizzes. So, okay, as you finish that up, you'll still keep the writing here, so you'll see it. But all right, so solve the algebraic equation, solve the log equation algebraically. How to rearrange the expression so that all the logs are on the same side. Combine each side to a single log and use your logs, and then we can isolate, or we can change the exponential form, just depending on what we can do. But essentially, especially if they're all logs the same base, we want to get them to be one log. So for example, on this one, we're going to go ahead and go, since they're all the same base, I'm actually going to leave this one here, just because, well, actually it doesn't really matter. Oh no, we want the x's together, excuse me. So looking at this, those have variables. So we want to get those together. Log 8 is a value. So that's like a constant. So like we want to kind of move, we can move that one away. Okay? So I want to go like this. Log x minus 2 plus, because I add this log x over. And I'm going to add the log 8 to the other side. And I'll show you why. So then that means that log x times x minus 2 equals log 8. And remember, if it's log same base equals log same base, now we can drop the logs. We're simply doing x times x minus 2 equals 8. So x times x minus 2 equals 8. And now we just want to solve that. So we get x squared minus 2x minus 8. And we're going to factor that. X minus 4, x plus 2 equals 0. Okay, so I get 4 and negative 2. Are those both answers? What's that? 4 is the only answer, right? Because negative 2, when I plug negative 2 in, gives me a negative argument. Okay, there we go. Okay, so remember, make sure you verify that your argument's within the restrictions of a log. All right, now we're going to go to some word problems and we'll be done. Any questions? Okay, this is just hopefully good general review. Hopefully it's not groundbreaking, but if it is groundbreaking, it's better late than never. Okay, all right, so solve the word problem using logs. So use the formula of y equals ab to the t over p. So I keep getting a lot of questions what t over p means. So t over p is used for if your time and there's periods within your time. So like, for example, if I'm doing 20 years, but I'm doing it 4 times a year, I want to divide those because it gives me the exact amount of times you're doing it. Okay? So that's what the T and the P are kind of talking about, especially with half-life. We're going to use that quite a bit. But let's just look at it here. So the half-life of phosphorus is negative 32. Or phosphorus 32, sorry. Not negative. Phosphorus 32 is 14.3 days. The length of time that it will take 96.2 grams of phosphorus 32 to decay to 12.5 grams to near state is what? So we have, this is my starting amount of phosphorus. I want to figure out how long it takes to get this much. And it gives me how long it takes to half. So what are we solving for within that equation? T. Good. We're solving for T. So if you fill out your equation, you're going to have, we know the base is what? Like B, like what's the growth? Like the B. Half. Right? Because it's a half-life. We know that the period is 14.3 days. Okay, we know that A is 96.2. And we know that the y, or the other side that we're solving for, is 12.5 is what we want. So we set up this equation. We have all that stuff. I'm going right from that equation there. It's going to be 12.5 equals 96.2, 1/2 to the T over 14.3. So why this makes sense is because why are we dividing the time by 14.3? That represents what? Yeah, it represents how many times that half-life. So if, for example, if I have 28.6, that's 2 half-lives. Okay, 14.3 times 2. So that's kind of what I want you to read that as. So we just solve this. You guys can do this. No problem. This is definitely a 2, sorry. Okay, so divide 96.2. Divide 96.2. Okay, so you go 12.5 divided by 96.2. They just leave it like that so you can stay exact instead of rounding it, which can give you some issues. Okay, so what do we want to do here? Yeah, we want to log both sides. And we need to log both sides here rather than switch to exponential form. Well, we could switch to exponential form. You could. We don't have to, but if you did, it would be log base of 1/2 of this equals T over 14.3. So you would do that. You can do that change of base and then do what to it? Multiply by 14.3. Yeah. So that's all we do. So if we log both sides, that's fine if you want to stay with that. Okay, I'm running out of room here. 12.5 over 96.2. I'm going to drop this in front already. So T over 14.3 is log of 1/2. And divide the log 1/2 and times by 14.3 will be our steps. Okay, divide the log 1/2 and times by 14.3. You should get 43 days if you round the nearest day. Any questions about that part that I tried to squeeze in there? Right, because again it says to the nearest day, so they want to get at least that 96.2. So don't round down. Always round up when you're trying to get to a number, because that means the first full day it happens. So, yeah, so she asked a question. So she said it comes out 42.1. We can't round to 42 because 42 is before what they're asking for. Okay, so I'm going to actually round up. All right, one more page here. All right, example of a student's summer job savings of $3,000 invested 12% a year, and it compounds monthly. How many months will it take for $600 interest? Okay, so we got to write our stuff down. So this is the form where we want to make sure we go a couple things, and a lot of you guys keep asking good questions on this. So you have your A equals P plus 1 plus I to the n. And so how many months will it take to earn at least $600? So it's important on this one that we go, your principal is 3,000. You take the 1 plus and you go I over the 12 because that's what it's compounding by. And they want to know when you're going to earn $600 interest. So you're trying to figure out, so it's not 600 here, it's what? 3,600 because it's past what you started with, right? If you put 600, you're going to get a negative rate because your money's decreasing. Okay. Okay. All right, and then to the end, just number of times it happens. So divide this over. So you divide 33,000 over first. If you divide that over, it should be a nice decimal, but they left it. What is that decimal? That would be 10.2? No, 1.2. Is it 1.2? Yeah. Okay, so divide that over, you get 1.2 equals, in there. Okay. So what is the I, though? We know what the I is. We can place that. No, you're right. It's 0.12. 0.12. 0.12 over 12, that's 0.01. So that means it's 1.2 equals 1.01 to the n. Yeah. So here's the question, and here's, what's that? Yeah, what I put? Yeah, 1.01, yeah. So here's the question, and if you're thinking, like you've told me, and I've told somebody this, that when it's compounding monthly, you have to divide the n by 12. But that's if you're doing what? Why do we do that? So here's my question. A lot of you keep asking me questions on these type of the problems, and we divide the interest rate by 12, and we usually divide the n by 12, because usually the n wants to know how long in what? Years, right. But this one wants us to stay in months, so we don't have to divide the 12 to the n. That's why I didn't do that. So let me say that one more time. If you read the question, student summer job saving is 12% per year, but it's compounded monthly how many months? So the n is months. So we don't have to divide this by 12. If n was years, we'd have to divide it by 12. Okay? Does that make sense?
So would you divide the 12 after? Did you do that?
You don't need to. What I'm saying is we don't need to divide n by 12 because we're staying in months.
But like if for some reason you just stick 1 plus I.
No, that has to be done before. Right. We have to do this before because we have to break up this right here is, because, yeah, every time it hits per year. Because okay, this is really good. Good chat. See here, 12% per year. So 12% per year means I need to do that now. I need to figure out what is per month. So essentially what we've done is everything's in months. Okay, you got the 12% divided by 12, so it's 1.01 per month. And months is our answer. We want to figure out when it's 1.2. If we ask how many years, nope. If it asks how many years, we'd still divide the interest by 12, but we have to divide this by 12 now. Days would be, if so, which part's in days? Do you want is the interest compounding? Is it like, so if you said your was compounding and daily, then you would divide by 365. Now, if you divide by 365, what is your n in terms of now? It's in days. So you understand that your n's days. But if you want years, then you divide by 365. See what I'm saying? So when you cut your interest rate compounding, if whatever you set, your n's now measuring that. But if you want to measure something different, you can divide that out. You guys good? Okay, so 1.2 times 1.01 to the n. Great conversation. Good job. We can use logs to solve. This one we can change a base. Doesn't matter. It's going to end up being log of 1.2 over log of 1.01. That's right over here. Log of 1.2 over log of 1.01. And n ends up being 18.3 months, so 19 months. They round up again. What's that? When do you multiply the n? You'd multiply the n if you were. You'd multiply the n if your interest rate was happening. If your interest was happening faster than the time that you were measuring. So if your interest rate happened per year, no, if your interest rate happened monthly, but you wanted years, so you'd multiply by 12. So it's like if it was flipped. So like if I said this 12% happens, 12% monthly. What's that? But yeah, then how many years? And I would times the n by 12. Yeah, that doesn't happen very often. Okay, how many years will it take for the value of a robotic technology which initially costs $575,000 to depreciate to $25,000 if it depreciates 25% per year? So first thing off, initially that's my principal, or my P is 575,000. My growth rate, my decay rate, technically, we can whatever you want to call it, is what do you write? 25% decay. What's that? 0.75. Good. Okay, so you got 0.75. Okay, and then we want to know when it's going to be 25,000. So you go 25,000 equals 575,000, 0.75 to the n. No interest rates here, nothing like that. It's a pretty straightforward decay question. This one's pretty straightforward. We divide the 575. And now we're ready to go. So we're going to now figure out what this is, right? It's essentially going to be log of this divided by log of that. Okay? So it would be, again, you can do it any way you want. That's what you get. And if you do that, we should get 10.89. So 11 years. 11 years for it to decay that much. Yeah. Okay, last one. All right, pH problem. Okay, the pH of a solution is given by the equation the pH equals negative log the H plus or whatever. If the pH of pure water is 7, then what's the pH solution that is 20 times more acidic than pure water? So remember on the pH thing, it's scaled by tens. So the pH of pure water is 7. What's the pH solution that's 20 times more acidic? Okay, so that means we want to go 7 first off. So 7 is my negative log H plus. That's my representation of the level of water. So what we're trying to do is we're trying to solve for water's pH level in terms of H. So it says the pH solution is given by the equation. So it tells me the pH level, right? So I'm putting 7. It says the pH of pure water is 7. So I put it here for pH. And I'm solving for that H plus or whatever to figure out its strength, I guess you could say. What's that? To the we're not doing the 20 yet. Because we got to figure out what water is and then go 20 times that. So right now I'm figuring out what water is. So to figure out what water is, we're just solving this log. We're solving for that argument. So I push this negative over. It's negative 7 log H plus. And then what would this be? 10 to the negative 7 equals H plus. So that's the answer for water's level, you could say. And so the solution, the pH of a solution is 20 times more. So 20 times more would be 20 times 10 to the negative 7. And so how could I calculate that, though, if they want to know the, but see it says what's the pH of it, though? That's just the, what I do right there. If water, that's just water's level. Is that water's pH? No, water's pH is right here. It's 7, right? So I had to find the level of it, 20 times the level, and now I need to figure out the pH. We have a pH formula. It's right here. This right here, if you're not understanding, this is H plus for that solution. That's H plus for that solution that's 20 times more. So all we have to do, guys and gals, is do this. Negative log 20 times 10 to the negative 7. That's the answer. you're going to calculate. Oh, perfect. You're welcome. Okay, pH level of that is going to be 5.7. So, what you can kind of, now, guys, this really like kind of makes sense to me because they say they go about 10, right? About 10 per pH. Well, water was 7. This one's 5.7. So that means it moved about 2 to the left almost. Okay, what's that? Is it not 5.7? All right, let's look here. All right, we'll pause the video.